Today we're going to start lesson 2, give the models a chance. We're going to be making probability models. Here's our learning goals for the lesson and some new key terms that we're going to be talking about today. So let's talk about this getting started. You had about 5 minutes to work independently, so we should be able to fill this in rather quickly. It says, Molly has 3 pennies, 4 nickels, 3 dimes, and 2 quarters in her pocket. So we're going to need that. That is important information. Underline it or highlight it if you have not already. She takes 1 coin out of her pocket and hides it in the palm of her hand. She wants her best friend to guess which coin she is holding. Complete the table. Use a fraction to represent each probability. So, the top part of our table is already filled in for us. The outcomes are all the coins that are in her pocket. A penny, nickel, dime, quarter. What was the probability of getting a penny?
3 out of 12.
How did you know that it was 3 out of 12?
Because I added all of them together.
So you added all of the outcomes? The 3 pennies, the 4 nickels, the 3 dimes, and the 2 quarters?
Yeah.
Why did we add these?
Because that would be part of our whole.
To get the sum so that we know what our whole is so that we can find part of it. Great job and great use of vocabulary. So we know she has 12 coins in her pocket. 3 of those 12 are pennies. So the probability of getting a penny is 3/12. What's the probability of getting a nickel?
4 out of 12.
4/12. 4 out of 12, because there's 4 nickels out of 12 total. Dime?
3 out of 12.
Great. Quarter?
1 out of 12.
2 out of 12. Nothing new. All we did was take what we learned from lesson 1 and organize it into a table. Number 2, determine the sum of the probabilities. What does the word sum mean?
Addition.
Addition. So we're going to take 3/12, add 4/12, add 3/12, and 2/12. That's hard to say. Our denominators are already all the same. So when I add, I can keep the 12 and just add the numerators. 3 plus 4 plus 3 plus 2 is 12, which is 1 whole. Great job. Question number 3, what coin would you advise Molly's best friend to guess? You say?
A nickel because since there's 4, then there's a chance that you're not going to.
Okay, great explanation. What were you going to say?
Oh, I was going to say a nickel because it has more than the rest.
There's more nickels. So it's more likely that Molly's picked out a nickel than any other coin. Let's talk about activity 2.1, using probability models. Jorge and Tristan are training to be magicians and are working on a card trick. They have 5 cards of different colors: red, blue, yellow, green, and purple. They are discussing the likelihood of an audience member picking each color, assuming that they cannot see the card's color. Number 1 says list the sample space for choosing a card. Right. Red, blue, yellow, green, and purple. Because the cards are labeled with colors, our sample space includes each of those colors. Number 2, what's the probability of selecting each card? Write the probability for each in the table. So here's our sample space. what would the probability be of picking a red card? 1 out of 5, 1/5, because there's one red card out of 5 total cards. What's the probability of getting a blue card?
1 out of 5.
1 out of 5. You go ahead and fill in yellow, green, and purple. Ask yourself, how many yellow cards out of the total number of cards? Omar, what's the probability of getting yellow? 1 out of 5. Ariel?
1 out of 5.
1 out of 5, because there's one green card out of 5 total. Lonnie? What about purple? 1 out of 5. Great. Great job. So here's our probability for each color. When solving a probability problem, it's helpful to construct a probability model. A probability model, underline or highlight this sentence, because this is another one of our vocabulary words. A probability model is a list of each possible outcome along with its probability. So that's what we just created. It's just a helpful way to keep our probabilities organized. We have our list of outcomes and each outcome's probability. A probability model will list all the outcomes, which will be greater than 0 but less than 1. So it's only going to list what is in the experiment. So like if this was our experiment, we wouldn't put pink as an outcome because there are no pink cards to pick from. So the probability would be 0 and we wouldn't include that in our table. This next sentence we need to underline. The sum, addition, of all probabilities will always equal 1. So if you were to add 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5, what do we get? 5 out of 5, which is 1 whole. Because our table lists every outcome, every possible outcome. Okay, let's turn the page. We're going to talk about a couple more vocabulary words, and then we will do some practice making the probability tables and using these vocabulary words. A uniform probability model occurs when all the probabilities in a probability model are equally likely to occur. Uniform probability models are when all the probabilities are the same. So in our magician trick problem on the previous page, all of those probabilities were 1/5, so that is a uniform probability model because they're all the same. When all of the probabilities in a probability model are not equal to each other, it's called non-uniform. So if all of your probabilities are not the same, we say that it is a non-uniform probability model. So let's practice with those. In activity 2.2, constructing and interpreting probability models. We're going to construct a probability model for each situation, then determine whether or not the probability model is uniform or non-uniform. Rolling an 8-sided polyhedron with the numbers 1 through 8. And just in case you are unaware, an 8-sided polyhedron is like a 6-sided number cube, but instead it has 8 sides. So our number cube had 6 faces An 8-sided polyhedron has 8 faces, 1 through 8. So if we were to roll that 8-sided polyhedron, what are all the possible outcomes?
1, 2, 3, 4, 5, 6, 7, 8.
So what would the probability of rolling a 1 be?
1 out of 8.
1 out of 8. Because there's one face that has a 1 on it out of 8 total faces. What's the probability of rolling a 2?
1 out of 8.
Again, 1 out of 8. Same reason. There's a 1 face with a 2 out of 8 total. Probability of rolling a 3?
1 out of 8.
Same reason. Go ahead and finish filling in this probability model. Because there's only one face with each outcome, your probabilities are all 1/8. So would this be a uniform or a non-uniform probability model?
Uniform.
Why is it going to be a uniform?
Because they're all the same.
Because they're all the same. So that's what we need to write underneath our table. Go ahead and try B. Choosing a model from a bag of marbles containing 1 green, 2 red, and 7 blue marbles. Outcomes, it's in this situation, it's going to be all the possible colors. The numbers describe how many of those marbles there are. Outcomes are the results. So if you were to pull a marble out of a bag, if I said, hey, go over there to that bucket and grab a marble, what could the result be? It could be a blue marble. What else could it be?
Red marble.
It could be a red marble
Green marble.
or a green marble. So our outcomes or our results are going to be green, red, or blue.
So the result of being green would be 1? Yes.
The probability, there is 1 green marble, yes. So the probability would be 1 out of the total number of marbles.
These are marbles.
How can we get the total number of marbles? Add the 1 green, 2 red, and 7 blue. So if there's 10 total and 2 of them are red, the probability is 2/10. Good job. And blue would be 7/10.
This is not uniform because they're not the same.
Correct. 1/10 plus 2/10 plus 7/10 does equal 10/10, 1 whole. This one's non-uniform because
They are not the same number.
they are not the same probabilities. Great job.
So we tell if they're uniform or non-uniform by the numerator?
Yes. We can tell whether they're uniform or non-uniform by the numerator. Because there's a different number of each color of marble, we know it's going to be non-uniform. On C, selecting a member of the chess club whose members are, this is what our sample space would be. Samuel, Martha, Carl, Carl, blah, 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 blah. Carol. Or Carl. I don't either. But this would be our sample space. So if we were going to choose somebody from the chess club, we could choose Samuel, Martha, Carl, or Carol, Carl, John, Sally, Ronald, Ronaldo, or Simon. So those are our outcomes. What we listed in the sample space are the outcomes.
ever met someone named Sally?
No.
I don't think she did.
So, how many Samuels are in the club in this list? 1. Out of how many total members? 7. And I heard you counting. 1, 2, 3, 4, 5, 6, 7. How many Marthas? 1 out of 7. Carol or Carl? John, Sally, Ronaldo, Simon.
They're all uniform. Yeah, they are.
And this is uniform because they are all the same. Great job. It is. Okay, let's finish up activity 2.2, and then we'll finish 2.3 tomorrow, and then we'll practice probability. We're going to skip D. Number 2, use the probability model to calculate each probability. The model is already done for us. We're just reading the model and answering these questions below.
I forgot what it says. Use the probability model to calculate each probability. Oh wait, we're doing this on our own.
Yeah, you can go ahead and do it on your own. Before you...
Sorry, I didn't know that.
It's okay. Hold on. Before you dive into this, D says the probability of getting a prime number.
What does that mean? I think a prime number is like... There should be. Oh, a number... Like kind of like a there's no number or non-number that okay, let's say the number 4. It can be multiplied by 1 times 4 and 2 times 2.
Right. So because the number 4 can be multiplied by 2 and 2 to get 4, it's not prime. A prime number is a number that can only be divided by 1 and itself. So that's going to be the number 2, the number 3, the number 5, and the number 7.
Oh, Dad. Wait, what? I got it mixed up.
So prime numbers are numbers that can only be divided by the number 1 and itself.
I thought it was multiplied. Miss, there's a PH and there's 8. PH.
Right. Right. Go ahead, yeah.
So how would you 0 out of 12?
Yep.
Wait, they can add numbers?
0 out of 12. You're right. It's not going to be 0 out of 8. Because your total is not 8.
So would we add the prime numbers
Yes.
together?
Yes. So you're going to add those probabilities together. No. This one, the probability of 8. Less than 8
I got 17.
is 7, right? Add the probabilities.
What? Oh!
1/12, 3/12.
No, my bad.
Well, you're going to include all of these, so it's going to be 1/12 plus 1/12 plus 5/12 plus 1/12 plus, because all of those, yeah. Or you can just think, if all of them are less than 8, what should they all add up to? Tomorrow, the first thing that we'll do is go over this, and then we will be able to finish activity 3 and start on a practice.